All right, I know you guys are so sick of exponents by now. I totally get it, and we've got one more learning target in this unit, and that is dealing with exponents that are negative and an exponent of 0. So these are kind of weird concepts, so I'm going to kind of show you a way to think about them. So in math, people often invent ways to extend concepts to areas that might not make sense at first. Pretty much everyone can understand what 2 to the 3rd power means, right? And we talked about this. 2 to the 3rd power means represents multiplying the number 2 3 times. So 2 times 2 times 2. Yet, what does 2 to the 0 or 2 to the negative 4 mean? Does it make sense to talk about multiplying by a number a negative amount? Like, can we do 2 times negative? What does that even mean, right? It's really hard to kind of imagine what that looks like. So let's do a little exploration of these two ideas, okay? So first we're going to start with the idea of 0. So here's a pattern. Fill in the pattern for powers that are not negative. What does this lead you to fill in for 2 to the 0? I don't know why that question mark's over there. It should be over here, okay? So let's look at this pattern, okay? So 2 to the 4th power, I'm going to put an invisible 1 here because, you know, I can put an invisible 1 in front of anything, and it's still going to be 2 times 2 times 2 times 2, right? I've got 2 times 2 times 2 times 2, and then times 1 still gives me the same thing. So the 1 is a placeholder, okay? Then I'm going to carry this pattern down. I've got 1 times 2 times 2 times 2 for 2 to the 3rd power, okay? And we can put what these equal. This is going to equal 8, and this is going to equal 16. Okay, so then this 2 squared is 2 times 2 times 1, which is 4. 2 to the 1st power is just 2 times a 1. So that leads me to believe that 2 to the 0 is just that 1 left over without the 2. Okay, which I know is very strange. I get 2 to the 0 equals 1. So we call this the 0 rule, the 0 property, okay, which says that anything to the 0 power is always 1. And I mean anything. If I have something like 2x to the 0 equals 1. If I have negative 3 to the 0, it equals 1. Anything to the 0 power will always equal 1 because of this pattern right here. All right? So this is a nice rule. This is an easy rule. Just anything to the 0 power, you put a 1. Okay? So that's the first rule of 0. Let's talk about the negative rule. And this is a little weirder. Okay, so follow me here closely. If positive exponents indicate multiplying the number 1 by 2 repeatedly, so if I have like 2 to the 3rd power, I am multiplying that number 2 times 2 times 2, right? I'm multiplying. The negative exponents should indicate, well, if negative is the opposite of positive, what is the opposite of multiplying? It is division. So negative exponents don't mean make the number negative. Negative exponents deal with this idea of division. So let's take a look at this pattern here. Okay, let's explore this for a second. So for 2 to the negative 1, I'm not multiplying 2 one time, I'm dividing 2 one time. Okay? For 2 to the negative 2 power, I'm going to have 1 over 2 times 2, because I'm dividing it twice, right? So 1 over 2 squared is 1/4. So similarly, I'm going to have for this next one, 1 over 2 times 2 times 2, which is going to be 1 over 2 to the 3rd, which gives me 1 over 8. And then the last one follows the same pattern of 1 over 2 times 2 times 2, which equals 1 over 2 to the 4th, which equals 1 over 16. So what I really want you to focus on in this pattern is this part right here. What is the connection between this and this? What's the connection between here? The connection between this one and that one. The connection between this and this. There's a pattern here. Okay, notice that this says 2 to the negative 4. The 4 stays the same, but it's positive and it's on the bottom. Same thing here. I've got a negative 3. It becomes positive and goes to the bottom. Same thing here. Negative 2 becomes positive and go to the bottom. Notice the base doesn't change. So this is the pattern of negative exponents. So we can make a rule about this. we can say that if I have a number raised to a negative value, okay, then I can change the power to be positive. So I'm going to make whatever the exponent is positive, and then I'm going to move that base, that term, to the opposite side of the fraction, which sounds very weird, I know, but when we see it in practice, you're going to get a pretty good sense of how it works. Okay, so negative exponents does not mean make the number negative. A negative exponent indicates movement. And I want you to write that down. A negative exponent indicates movement. That's kind of a hard thing to wrap your minds around because you're so used to negative numbers making the value different, making the sign change. This isn't a sign change particularly. It is a sign change and a movement at the same time, okay? So how does this look like in practice? So put this little what picture because I know a lot of you are thinking like this cat is thinking, like what is she talking about? So let's look at what this looks like in practice. So this question says, which of the following is not equivalent to 5 to the negative 2? So when I see 5 to the negative 2, this indicates to me that I need to create a fraction. And this 5 to the negative 2 needs to go on the bottom and become positive. So that is how 5 to the negative 2 gets rewritten. It gets rewritten as a fraction, okay? Because really, this has an invisible 1, and all I'm doing is kind of moving it to the denominator because it's automatically in the numerator, and I'm making the sign positive. So that checks off this one. That is equivalent, right? And then what is 5 squared? 5 squared is 25, so this one is also equivalent. Okay, what about this 1 over 10? Is 5 squared 10? No, so that has to be the right answer here. That one's not equivalent. And if you're confused about the decimal, if I go to my calculator and put in 1 divided by 25, I bet it's going to give me 0.04, which is what this says here. So 1/10 is the one that's not equivalent. And sometimes students get confused because they see this 5 to the second and they sometimes think to multiply 5 times 2, but really you're multiplying 5 times 5. Okay, so that's kind of one way to think about negative exponents. Another way we need to practice negative exponents, and we did this a little while ago in a previous learning target, is being able to plug things in and evaluate. So remember, function notation means you plug this in. So I'm going to replace x with negative 2. So I end up getting 12 parentheses 2, and I'm replacing this with negative 2. Okay, so here's where things get strange. I'm going to write this as a fraction because negative exponents create fractions a lot of times. So I'm going to put that over 1. It's a placeholder. Okay, so I'm going to leave the 12 up top because it doesn't have a negative exponent. But this 2 has a negative exponent of negative 2. So that 2 gets moved to the bottom, and this guy becomes positive. Okay? So that's what I mean by indicating movement. You move the base it's attached to. You don't necessarily move this coefficient. Now all we have to do is evaluate. 2 squared is 4. 12 divided by 4 is 3. So that is what happens when we plug in negative 2. We get a 3. Okay? So remember, negative exponents indicate movement within a fraction. All right? So how do we simplify expressions with exponents? So we're finally getting to the point where I want you to realize that we don't ever want to see negative or 0 exponents in our answer. So look at all these exponents. None of these are simplified because I can see a 0 exponent and I can see a negative exponent. We can't have that. All exponents have to be positive, greater than 0. So to simplify, all you have to do is do the movement. 5 to the negative 3, flip it, put it in the denominator, and make the 3 positive. If you need to write this over 1 to help you, you totally can. I just know that automatically that's in the numerator because it doesn't have a 1 to make it. It doesn't have a 1 over it to make it a denominator, so I know to put it in the denominator. The next one's easy. Anything to the 0 power is 1. So that's done. 2 to the negative 5. I'm going to take that 2, put it on the bottom, and then make the 5 positive. 1 over 2 to the 5th. Okay, and with numerals, you can make this, you can put 2 to the 5th in your calculator. I kind of don't want to do that. Actually, I was going to, I'm not going to, because I want you to understand how the exponents work. I'm not going to give you numerical ones, so I want you to realize how to rewrite it. Okay. The next one, be careful here. This is saying x is to the 0 power, not the 4. So the 4 stays, and x to the 0 becomes 1. I like to cross them out because it doesn't do anything to your problem. 1 becomes invisible when you multiply. So I just sometimes like to cross that 0 out. This one, on the other hand, is saying this whole thing is raised to the 0 power. So if that whole thing is raised to the 0 power, then the whole thing gets crossed out and becomes 1. The last problem is a little trickier. I've got x to the negative 2, y to the 4th. Well, this 4 is positive, so that y to the 4th is going to stay right where it is. It's not a negative, there's no movement, but this x to the negative 2 gets moved to the bottom and becomes positive. So this is the basic idea of negative exponents and 0. Okay? Negative exponent indicates movement, 0 indicates 1. So now we're going to move on to some more complicated expressions, combining kind of what we've learned so far with what we're working on in this learning target. So, this first one, okay, whenever you've got negative exponents, I always create a fraction. I'm just going to look at all 3, and I know that there's going to be a fraction involved because negative exponents indicate movement. So I always write a fraction when I see negative symbols. I always do. Your final answer might not be a fraction, but as you start to simplify, you're going to be working with a fraction. So just to be safe. And then I ask myself, I say, okay, do I need to move anything? Well, do I need to move the negative 2 right here? Does it have a negative exponent? The 2 is negative, but it doesn't have anything up here. There's nothing up there, so that negative 2 stays where it is. Don't confuse negative numbers with negative exponents. That negative 2 stays. And then I'm going to cross it off because I'm done with that. The u squared, that also stays up top because it's positive. But this v to the negative 4 moves to the bottom and becomes a positive 4. Okay? So you have to look at each term and ask yourself where it belongs. Okay? Now, this one's a little bit trickier. Okay? And for this one, I told you guys to write division symbols, and this is one of the examples where it's not really going to help you. So before I do my fraction symbol, I'm going to go ahead and get rid of these parentheses first. Okay, and then I'll come back to the fraction symbol. So when I do that, remember you multiply exponents. So this becomes x to the positive 12 because negative 4 times negative 3 is positive. Okay, and then what's 0 times negative 4? It becomes y to the 0. And I'm going to bring this stuff down. Okay, now I can go ahead and put my equals in my line. Okay, that's my bad. I shouldn't have said always put the line. You kind of have to do some simplifying first. So when I look at this, I'm going to start one by one. X to the 12. Where does it go? It goes up top. Boom. Cross off. Y to the 0 just gives me 1, so I'm going to cancel it out. X to the 4th. That goes up top. Next to the 12. Cross it off. This y to the negative 3 goes to the bottom and becomes positive. And then my last step is just to add these exponents together because they have the same base. So I get x to the 16th over y to the 3. Okay? This one, I'm going to go ahead and do my movement first because I don't have to multiply anything. I didn't mean to erase that. Okay, so I'm going to look at each term and see if I move it. Do I move the 2? Nope, it stays. Cross it off. Do I move the y? Yep, it goes down here and that 4 becomes positive. Cross it off. Negative x. Nope, that stays up top. Okay, and y to the negative 2 goes on bottom. Now I simplify. 2 times negative x gives me negative 2x, and on bottom, y to the 4th, y to the 2nd gives me y to the 6th. Okay, so think about this in terms of movement. Where am I moving things? And then think about how you're simplifying it. Okay? All right, we've got a few doozy problems coming up here. I don't want you to freak out. Just relax, take a breath. I'm here to help you, okay? So, I'm going to put my equal sign, I'm going to put my fraction. Especially if the problem starts with a fraction, this will be your next step. So let's simplify the numerator. I've got the 2, it's not going anywhere. This has a little invisible exponent of 1, so when I multiply these, I get x to the 3rd because I add them. Those are done. This right here, I'm going to have to multiply that, so I end up getting x to the negative 2. Now, I can't be done here because I have a negative exponent, and I just told you guys you can't have negative exponents. So now you think about movement, right? The 2 and the x to the third don't move because they don't have negative exponents, right? But does this x to the negative 2 move? Yes, and where does it move? It moves up. It moves to the opposite side. So this actually becomes x squared, and there's nothing left down there. This goes away, and it moves to the top, and then the bottom is just 1. And we don't even need to write that 1. We can just write this as 2x to the 5th, because the 1 on the bottom doesn't matter. Okay? So if it's something in the bottom, and it's negative, it goes to the top. If it's negative in the top, it goes to the bottom. Remember, indicates movement. All right? The next one, I see a couple y zeros. I'm just going to cross those off. They mean 1. They can just be crossed off. It doesn't matter what they are. Okay? Now, let's distribute the negative 1 to these guys. Remember your little invisible exponent. So this becomes 2 to the negative 1, and this becomes y to the negative 1. And on bottom, I have y to the negative 3. Okay, now, where are you moving things? Okay, the first thing we're going to look at is, where do I move this thing? Where do I move this? Does that stay up top, or does it go on the bottom? My highlighter pen, I don't have good luck with that, guys. That 2 to the negative 1, that's going to move to the bottom and become 2 to the positive 1. Gone. How about y to the negative 1? That's going to move from the top, and it's going to move to the bottom. Gone. The y to the negative 3 is going to move up to the top and become positive 3. And to make this look really nice, we're going to get rid of those little invisible ones. And now we can kind of see that 3 minus 1 is 2, right? So 3 minus 1 gives me 2, but that y squared, the third is the bigger number, so y to the 2 lives on top. Okay, because we have to simplify this thing. All right. Now, I know this problem looks really scary, but think just for a second. This is saying all of this crud inside of here is raised to the 0 power, so that means this answer is 1. Like I said, anything, no matter what's in there, raised to the 0 power is 1. So you could just cancel the whole thing out and write 1. Okay? All right, we've got 4 problems left, and these are the hardest ones we're going to have in the unit, okay? And please focus on this whole don't panic. This is important. I don't want you guys to panic. You are all capable of following these laws. I believe it in my heart. So I've given you a list of steps that tend to work, that I use. So step 1 is the power rule. So that's the first step that I'm going to do here, is the power rule. And that's getting rid of all of the, like, exponents to exponents. Those double exponents things is what the power rule is. Okay? So step 1 is to remove all the parentheses. Okay? So when I see this parentheses right here. I see this negative 3 parentheses. So I'm going to get rid of that. So negative 3 times 1, that gives me 2 to the negative 3. And then the v becomes v to the negative 6. And then I'm going to just rewrite everything next to it. There's no need to try and do more complicated things. Okay? The next step is the movement step. That's the negative rule. Okay? By moving them up or down. So I'm going to look at each individual term, and I'm going to ask myself, where does this go? So this guy, the 2 to the negative 3, that is a negative exponent, so when I draw my another line, that goes on the bottom and becomes positive, and I cross it off because I'm done with that. The next term, v to the negative 6, that becomes positive, moves to the bottom, cancels out. 2v to the third doesn't move. It's not negative. It doesn't move to the bottom. And this v to the third down here, that doesn't move either, so it stays on the bottom. Okay? I'm going to leave the top alone because I've got some stuff in the bottom to deal with. 2 to the third power is 8. And v to the 6th times v to the third is v to the 9th. Then I see that 2 divided by 8 reduces to 1/4. And now that I have these two on top, okay, sorry, that's what I did here at step 3. I did the product rule. That's what this was. And then step 4 is now subtract the exponents using quotient rule. Well, 9 minus 3 is 6, and this is the bigger exponent, so I've got v to the 6 on the bottom. Okay? These problems are all manageable as long as you create a system and follow it. I think this is a good system that I've come up with. It works generally most of the time. So we're going to keep trying to use that. Okay? All right. So first step here, I'm just going to rewrite that top thing because I don't want to move yet until I've gotten rid of the parentheses. I also noticed that's a 0, so I'm going to cross that off. I don't need that. That's just confusing. So I'm going to put my little 1s up here, and I'm going to make my little distributions, and I'm going to rewrite that. So the first one becomes 2 squared. Okay, done. The second one also becomes 2 squared, so that's done. This becomes u to the -2. That's done. And this becomes v to the -8th. Notice I'm crossing things off so I know what I've done and haven't done yet. Okay. Next step. Okay. Now I'm going to simplify the denominator, right? I don't want to move anything yet because this denominator is a mess. Okay, 2 squared is 4. This 2 squared is 4, and 4 times 4 gives me 16. Done and done. Okay, and then I'm just going to copy this down here. Okay. Now I do my movement. Now I ask myself, where does everything move? Well, the 2 doesn't move because it doesn't have a negative exponent. Cool. The v definitely moves here. That v is going to go to the bottom and become 4. Cool. 16 does not move. In fact, I'm going to put the 16 in front because it's easier than the v to the 4th here. Okay, 16 stays. This u to the -2 moves up here, and the v to the -8 also moves up there, and they all become positive. Now we can do our quotient rule and start dividing. 2 divided by 16 gives me 1/8. That's done. Here I've got v to the 8th and v to the 4th. I know the u's and v's look very similar. I'm sorry. So 8 minus 4 is 4, and the 8's on top, so I've got u squared v to the 4th on top, and I'm going to rewrite this to make it look a little bit neater like that. Okay? All right, we've got 2 more here. Okay, same. If you want to try these on your own, I encourage it. If you want to try these on your own and then pause and unpause, for real, I think that's a great way to learn, and I always encourage it. I'm still going to walk you through it, but I think it's a great way to learn and test whether you're paying attention. I'm going to go ahead and cross these off right away. I'm going to get rid of these parentheses by distributing these to the inside. So I get -2 to the 4th power, and then I get y to the 4th power, and I'm just going to rewrite these things up top and rewrite the bottom, -x to the -4th. Cool. All right, now I'm gonna do my numbers. I've got this -2 to the 4th, which I know -2 to the 4th is 16. Because -2 times -2 is 4, 4 times -2 is -8, and then -8 times -2 is positive 16. And so then I know that 16 times 2 gives me 34. So I've got, 32. So I've got 32 up here, and these are gone. And I'm just going to rewrite the x to the 3rd and the y to the 4th. Do you notice my strategy of like circling numbers and then crossing them off once I've done them? If you try and do all this to your head by looking at it, which I know you guys will try and do, and I'm going to say it a billion times, you're going to make mistakes. So please follow my strategies. It does work, and I'm 31 years old, and I've been teaching algebra for 6 years, and I still do that. Okay? The bottom, I'm just going to rewrite as -x to the -4. Okay. Now, I know I've got this, like, I'm going to move everything, but before I do that, this little -1's bothering me. I know I've got a negative in the bottom and a positive up here, so I'm going to cross this off and attach it to the -32. That's an allowable thing. You don't have to do that, but that makes more sense to me. Now I'm going to move stuff. X to the 3rd stays, y to the 4th stays, but this x to the -4th comes up here and becomes +4, and the bottom is gone. Everything in the bottom canceled out, so the last thing I just have to do is combine my x's here, the 3 and the 4, to get x to the 7th, y to the 4th. Okay? We've got one more. Hang in there, guys. You're doing great. Okay? Last one, and I put this cat one because I needed you guys to have a little bit of a laugh, and I do think that's awesome that Taco Cat spelled backwards is still Taco Cat. I find that super awesome. Okay, so before panic sets in, first thing, cancel out that 0. We don't need it. And what I like to do with ones like this is I'm going to do my little coefficient guy, put the 1, put this one here, and I'm going to distribute that -3 to every single thing in here. Okay, that's a lot of lines. Okay, it's 6 actually. So, but this is going to get rid of those parentheses. So I'm going to have, sorry, I can't read that. Is that a negative 3? Yeah. So I'm going to have a to the positive 3, because negative 3 times negative 1, b to the positive 6, and then negative 2 to the negative 3, and then, I can't read, oh, b's the 0 canceled out, so that's the top. On the bottom, I have negative 2 to the negative 3, I've got a to the negative 12, and I've got b to the negative 6. Now, I want you to notice something really important here. I need you to notice that this guy and this guy are the same. And if you've got something that's the same on top and the same on bottom, they cancel out to 1. So, like, they're gone. You don't have to worry about those two things because it was the same on top, same on bottom. Cool, it's over. Now that that's done, now I just have to think about movement. The a to the 3rd stays, the b to the 6th stays, this a to the negative 12, goes up top and becomes positive 12, and this b to the negative 6 goes up top and becomes positive. And then look, your whole denominator went away, and all you have to do now is add your exponents. 3 plus 12 is 15, so you have a to the 15th, and 6 plus 6 is 12, so your final answer is just this little simple guy. Okay? You guys have done really great paying attention. I know this unit is really hard. I understand that it feels kind of pointless. I'm with you. I get that. I need you guys to show some grit, like we say, and really strive to do well here. It's your last learning target, so do your best. Take your practice seriously like always, and I'm here to help you. Good luck.